question 9 together, and we talked about it being semi-annual, and that's 2 times a year, and so we worked this problem out. They're not drumsticks. It's a compass for chalkboards. My math teacher in high school called it a double-barrel nose picker.
A double-barrel nose picker?
Yeah. All right, now, suppose we change this to monthly. So you're going to get interest 12 times a year. What would that make your end value? Whoa, wouldn't it? Okay, so redo this question. Obviously, none of the answer choices are correct. Find out how much that 16,000 turns into after 8 years. We know that if it's semi-annual, we would have gotten 40,646. Let's see what happens when it's compounded monthly. For you, I would start with inside the parentheses. So you got 1 plus 0.12 over 12. So that's the first part I would type on your calculator. Did you type that part? 1 plus 0.12 divided by 12. And then I would use a caret, and then I would use a parenthesis, 12 times 8. Yes, it has parentheses. It will work. So I'm walking you through it. The very last thing you do after you hit the equal sign after this is to multiply by 16,000. What? No, it has a y to the x button. It has a y to the x button in the upper right.
And then it's 12.
You use a parenthesis, and then you type 12 times 8, and then an end parenthesis, then an equal sign. So after you get done hitting this parenthesis, you hit an equal sign. Then the last thing you do is to multiply times 16,000.
The other one I can try.
Order of operations killing you there, kid?
No, I just...
That calculator.
Yeah, I just calculated how to do it.
You have to, you have to know how to, use it. It is an old school machine. Yeah, exactly.
And then on the caret, it's 8. God, how can you
What?
I literally, that would be, I feel like that would be the biggest factor in high school dropout. The fact that you'd have to sit there and multiply everything.
So,
You can't do everything
They
You
on
literally
paper.
basically waste your life for this to happen.
So you're really wasting your life when you get out of college and you have like
Nope.
Okay, let's be honest.
And you actually know how to do things?
Half of people don't use it.
I'm talking about like back then.
Okay, so you should get a number larger than 40,646, okay? Okay, now, what I would like you to do is subtract the number that you found on your calculator from that number on choice C to tell me how much more interest you would get. How much more interest would you get if it was compounded monthly versus folks, just by changing that one thing, $942.37. Okay? So obviously we got 41,588.37. And then when we subtracted these two, we found out there was a difference of $942.37. Might not be completely exact because it looks like we rounded choice C. Okay. On a lot of the questions before, I crossed off a particular formula, and now we're going to be using that formula. Okay? Continuously compounded. There's a new phrase. That phrase is going to lead us to a different formula. You really need to pay attention. Now, I do realize, folks, that a long time ago, there was a guy by the name of Leonhard Euler. His last name looks like Euler, but it's pronounced Euler. Okay? Now, he was a super nerd. And so he was looking at this formula. That's a lot of super nerds do. Okay, now that looks kind of like the compound interest formula. You need to pay attention. Not ignore me. How much money was invested in Euler's formula? How much money? Right here. $1 was invested. Okay? What percent interest rate? 100%. Folks, that's the decimal equivalent of 100%. So we're effectively doubling our money every year. And then he said, for how long? How many years? Right there where I'm pointing with my finger. 1 year. He started messing around with this number n, and he raised it significantly. And what he noticed was, you get more money, more money, more money, more money, but it's slowing down. It's getting close to a particular value. And so he realized that it was getting closer and closer to this irrational value, which never stopped, never repeated, and it was approximately 2.718. So in order to honor him, because this is used in what we call continuous compounding, they named it after him. So they called it E. It's programmed into every one of your scientific and graphing calculators. Look and see if you can find it on your calculator. For the graphing calculators, a lot of times it's on the left-hand side. There's a button that looks like LN. It's not IN, it's LN. And right above it, it says e to the x. So you might be looking for something that looks like that, e to the x. Okay? Do me a favor right now and type in e to the first. E to the first. See if you can get 2.718, blah, 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 blah. Got it? Yep. All right? Now, why on the outside of my room does it say this? So that is Mr. Stale E. Now, that is the extent of my nerddom. I'm not the guy who's going to sit there on a Saturday afternoon and plug in larger and larger values of n to see what happens to the formula. Okay, that's just not me. You know, I'm not quite on that level.
You have to do other things.
Yeah. I calculate my taxes. So, the compound interest formula changes. It changes to this thing. So the whole set of parentheses that's in the middle of that formula that we were dealing with changes into that thing right there, which actually is going to make it easier to calculate. So let me do number 11 with you. $4,000, that's how much we're starting with. E, the interest rate, 5.5%, so what am I going to put in there for R? What am I going to put in there for R? 0.055. If you put 1.055 in there, guess what? You're going to be more than doubling your money. Fantastic, but completely unrealistic. Remember, in the other formula, it had 1 plus R over N. We don't have that in this. So, use your machine and see if you can come up with the value. probably off one decimal.
Yeah,
One.
that one.
You should be able to show me that you got 4,465.11. Okay, so that's how much money will be left at. Will be in there after 2 years.
Would that be wrong on its axis?
Well, it does not round to 1-2, but remember, if the bigger question is, how much work are you going to show me? Are you going to show me this entire formula? If you're going to show me this entire formula, and then your number next to it is off by 1/100th, I think I can forgive you. Okay, but you better be showing me the work, because if you don't show me the work, I don't know what I can do. I probably will take off if you're coming up with answers that aren't quite right and you don't have the work. Very important. Show the work. Okay, so your job right now on 12 is to work it out. Change the value.
I got that too.
Good. So 0.051 times 4. Hopefully you got what Mr. Duncan just quoted to me, 2452.6. Now, the truth of the matter is it's like 2452.596, blah, blah, blah. Now, I got a question for you. Do you think the bank would round up in your favor or down in theirs?
Down in there.
Oh, yeah. So now, I'm not going to argue, once again, Mr. Bond, to answer that question about rounding. I wouldn't argue with a kid if they showed their work, and then one kid put 5.9 and one kid 6.0. I'm not going to argue with that, because I understand.
It's like it did.
Well, the truth of the matter is the bank's always going to round in their favor and not in yours. Okay? That's why they keep building more banks.
There's a law.
Days are over.
You had to build a church for every street.
Wait, that's not really.